Identifier scope and storage class determine when and where you may use an identifier or a variable. Let's make a working copy of working.c, copy and paste it into the working project, and double-click to open it in the editor. Scope refers to the places where an identifier may be safely used. For example, if an identifier is declared outside of any functions or blocks, it's visible from the place it was declared until the end of the file. So if I go ahead and declare an identifier out here, I now have a variable named number, and if I want to print that inside of this function, I can say save that and run it. Sometimes we get this launcher thing, and it says the number is 7. Now on the other hand, if I take this and I move that and put it after the function where it's used, and if I save that and try to compile it, we're going to get an error. And our error here says number is undeclared because it's actually declared after the fact. So when an identifier is declared outside of any functions or blocks, it's visible from the place it was declared until the end of the file. And here it is not visible to this function because the function happens before the declaration. So we'll go ahead and move that again, and we're going to declare it inside the block. Now it'll be visible again because it's declared inside of this same block and before it's used. So if I save that and run it, but if I were to declare it inside the block but after where we're using it, now we're going to get an error. See, we've already got this error showing up here. If I try to compile it, we're going to have that problem again. And if I were to declare it inside of another block, let's say if 1, which is always going to be true, and I'll just declare that variable inside of there, but it's inside of that block, it will not be visible out here either. Try and run that, and we get the same error. And we also get an error that it's an unused variable. So that's called identifier scope. It talks about the scope in which a variable or an identifier is available. Scope is not to be confused with storage class. Storage class refers to when, where, and how the storage space for a variable is allocated and deallocated. Storage class is sometimes referred to as storage duration, and there are 4 distinct storage classes available: auto, static, extern, and register. Auto is the default storage class for a variable defined inside of a block. So here, for example, we've defined this integer inside of this block. So its default storage class is auto, which means that it's allocated in temporary space. And so here we'll save this and we'll run this, and we see that it works fine. And this is an auto variable. So the space for that variable is actually allocated at that time inside that block, and it's deallocated at the end of the block. Now let's put all of this inside of a loop so we can take a look at the difference between auto and static storage duration. For int I equals 1, I is less than or equal to 5, and increment I. We'll go ahead and close the block here and indent it for clarity. So now the interesting thing here is that when I save this and run it, you see we have the number 7 5 times. If I increment that, I'll just put a ++ after I use it. So now it gets incremented each time, but it's still going to be the number 7 5 times because it's auto storage. It goes away each time. On the other hand, if I make this static, I say static int number 7, now it's no longer auto storage. Every time through the loop, it's using exactly the same storage space. And so when I run it, it actually gets incremented. It starts at 7 and it goes up 8, 9, 10, 11. That's now static storage. It's permanent. It stays there, and it can be reused. We're going to skip extern storage for a moment, and we're going to talk about register storage. If I say register here, you'll see that it works just like auto, so I'll save that and run it. You see it says the number 7, the number 7. The distinction here is that you're giving the compiler a hint to try to store this variable in a register of the processor rather than storing it in temporary storage space. And this should make it faster. The reality is if you're using any optimization in your compiler anyway, the register keyword is probably going to be ignored. And the optimizer is going to choose variables that are used in certain ways and put those in registers if it can to make them really, really fast. So even though this keyword exists, it may or may not be implemented in certain ways. Modern optimizers are usually better at this than the programmer, so it's best to use this only where it's absolutely necessary. Now let's talk briefly about extern. What I'm going to do here is I'm going to grab this func.c and I'm going to copy and paste that into our working space. I'm going to open that up. And now we have two files open. We have func.c and working.c. We have a problem here. We have this func.h. I'm going to delete that. I'm also going to delete this main because we're not going to use that. And so what we have here is we have a function called func, and I'm going to just also declare a variable int. I'm going to call it var, and I'm going to give it a value 47. Because these are in the same folder and we're using Eclipse, this will go ahead and get compiled and linked together with our working.c. And so I can declare up here, I can say extern func, and what's my function? It's just a void. So I'm going to say extern void func like that. And then I can call it from right here. I can say func, and it will get called. And if we look over at what it does, it just printfs this is in the function. And when I save that and run it, you'll notice that this is the function because that's what's in our function over there. So that got actually run. If I take out this extern void func declaration and try to run it, you'll notice that we get an error right here, implicit declaration, and that's not allowed. So we'll put that extern void func back in. So the external storage class means this is something that's in a different translation unit. It's in a different source file, and it gets linked together at link time. And so this tells the compiler, don't worry about it. We'll link that together when we do the linking. So I'm going to save that and run it, and that should get rid of our little error thing there. We can do the same with the variable. I can say extern int var, and now I can actually print that. I can come down here and I can say printf extern var is %d, and a new line, and var. And that'll actually, you see this variable over here is the number 47. So that will actually go ahead and print that. It says the extern var is 47. So this external storage class, extern, it tells the compiler, this is something that's defined elsewhere, but we're declaring it here because we're going to use it here. But it's actually defined in a different file in a different translation unit. So scope refers to where an identifier is visible, and storage class refers to how and where the storage is allocated for the identifier. Understanding these concepts is important for writing code that is efficient and reliable. Now let's delete our working files and run clean to get set up for the next lesson.